In the previous lecture, I introduced the concept of a linear regression, which is finding a line that passes through your experimental data that might be used as a predictor of some dependent variable. So in this case, in this set of lecture, we're just going to talk quickly about the mechanics of how you actually go about doing that. So we're going to walk you through that and then look through a pretty simple example. All right, so here's the problem we have. We have some measurements with the independent variable, in that case represented on the x-axis, and dependent variable measured on the y-axis. And then we're going to find the properties that characterize this line, which are essentially the slope and the y-intercept, right? Like any line. Those are the values that we're going to be looking for. All right, we're going to want to select the values of the slope and the y-intercept. They're going to some way minimize the departures from the regression line. So this is the regression line, that's the dotted line. The departures are the difference between the measured values and our predictor of those measured values. And we want to come up with some measure of a typical departure and then minimize that. And so not surprisingly, you might think to use the standard deviation of those departures. And that essentially is kind of the standard method. We're going to minimize the standard deviation of those departures from the mean. And in doing so, we're going to find the m and b in y equals mx plus b that minimizes sigma d, right? Sigma is just standard deviation of these values d, which are the departures. So here's d1, d2, d3, d4, and then d5. All right, so how do we do that? And I'm not going to go through the derivation, but the results are essentially shown here. So for y equals mx plus b, we're going to take m is going to be equal to the sum of this value where xi minus x bar being the sample mean, and then y times yi minus y bar, and that's the sample mean of the y, or the dependent variable. And yi and xi are like your individual measurements. So in this case, I goes from 1 to n, where we have n measurements. And we're going to divide that by this value, which is xi minus x bar, that'll be the departure from the mean of x squared. We sum that up, we divide that, and we end up with m. And then b is just going to be equal to the mean of y minus m times the mean of x. All right, so let's just go through a quick example where this is done. So in this case, it's the same example we had before. We have 5 people, and we know the number of hours studied and what grades they get. That would be in points. And so I'm in this fourth column, fourth column here, we're actually taking the number of hours studied minus the mean number of hours. So here are the averages here's the average number of hours studied, 3.4. So in this case, this student studied 0 hours, so his hours minus mean hours is negative 3.4. And then he ended up, or she ended up with a grade of 22. The average was 49, so the departure, the grade minus the mean grade, is negative 27. So that's like our xi minus x. And this xi minus x would essentially be like that negative 3.4 value. Then yi minus y bar, that's essentially the negative 27 value. And then we're going to take the product of those two. And that's what this column is here, where it says product. Okay, you end up with 91.8 for this first student. And then finally, to get in the denominator, we need to take the hours minus the mean hours and then square that. So that's what we do for that person. Okay, now to do this summation, this is essentially, this summation in the numerator is essentially this value here, 148. Okay, and the summation in the denominator, that's this value over here. That's 23.2. So we take m is essentially going to be 148 divided by 23.2. We end up with 6.38. And then we take that m value and we substitute it into here, where y bar is 49. and X bar is mean number of hours studied, that's 3.4. And we subtract those y bar minus mx bar, and we end up with b. That's the y-intercept. So that shows that the line, actually I think on the next, so you have m is 6.38, b 27. So this slide shows you the results of the regression calculations that we carried out in the previous slide. So we have the grade equals 6.38, remember that's our m value, times the study time, plus 27.31, that's our y-intercept. So you can see right here, here's my y-intercept, about 27, and then it goes up on a slope of 6.38. And it does a reasonable job of basically passing through all of my measured points. You can imagine you could even extrapolate this if you believe the extrapolation. I'm trying to draw a straight line. That's not too bad. So you can see if a student studied 7 hours, our prediction of their grade would be up here about 74 points. Okay, and we could also extrapolate it. Oh, you can't extrapolate to negative hours. That would be difficult. But extrapolation versus interpolation is just a concept you need to be aware of. And then if we had, for example, a student that studied 3 hours, we'd basically come up here, and then we go across and say, well, I predict that that student is going to have a score of about 46 points.